Namaskar. Very warm welcome to all the viewers and learners in this live interaction of CIET NCERT. I am Renu Bhatt with you all and you are watching us live on eVidya channel, channel number 11. And apart from this channel, you are with us on our YouTube channel as well, that is NCERT Official. डियर लर्नर्स, मैं हूं रेणु भट्ट, आप सभी का स्वागत करती हूं अपने इस लाइव इंटरेक्शन में। और आपको हम बता दें कि NCERT ऑफिशियल के अलावा भी आप हमसे हमारे एक और यूट्यूब चैनल के माध्यम से जुड़े हुए हैं, जो है PMeVIDYA क्लास 11। आप इस चैनल पर भी हमारे साथ जुड़े हुए हैं और आज के इस सेशन में हम बात करने वाले हैं फिजिक्स के 11th स्टैंडर्ड के स्टूडेंट्स के लिए। एंड द टॉपिक दैट वी आर गोइंग टू डिस्कस टुडे इन दिस स्पेसिफिक सेशन इज लॉज ऑफ मोशन। और आपने ये टॉपिक अपनी प्रीवियस क्लासेस में भी पढ़ा है और आप सभी को इसके बारे में कुछ ना कुछ ज़रूर पता होगा। इन लॉज के बारे में आपको डिटेल में बताएंगे हमारे एक्सपर्ट। मोशन के बारे में हमें बताने की ज़रूरत नहीं है, बहुत ही इंपॉर्टेंट चीज़ है और हम अपने आसपास डेली रूटीन में ये चीज़ें देखते रहते हैं। बिना मोशन की चीज़ें संभव नहीं है और इस पर आपको डिटेल में इंफॉर्मेशन देने के लिए हमारे साथ हमारे एक्सपर्ट जुड़ चुके हैं। तो विदाउट एनी फर्दर डिले लेट्स क्विकली मीट हिम। यू आर मिस्टर आई के गोगिया सर, आपका बहुत बहुत स्वागत है।
नमस्कार, थैंक यू।
और अपने सभी देखने वालों को हम बता दें कि सर फॉर्मरली पीजीटी फिजिक्स हैं, केंद्रीय विद्यालय संगठन नई दिल्ली से। अगर आपके मन में कोई भी क्वेरी आ रही हो डियर लर्नर्स एंड व्यूअर्स, अगर आप इस चैप्टर में कहीं पर अटक गए हैं एंड इफ़ यू वांट टू नो मोर अबाउट दीज लॉज, आप हमसे जुड़ सकते हैं हमारे विभिन्न माध्यमों के द्वारा। आप हमें कॉल कर सकते हैं हमारे टेलीफोन नंबर पर जो है 8800 440 559। ईदर यू कैन ड्रॉप अ मेल एज वेल। हमारा ईमेल एड्रेस है dth.class11@ciet.nic.in। अगर आप YouTube चैनल्स पे हैं तो वहाँ पे लाइव चैट बॉक्स में जाकर अपना कमेंट ड्रॉप कर सकते हैं। ये सबसे तेज़ माध्यम है हमसे जुड़ने का और हम चाहते हैं कि ज़्यादा से ज़्यादा संख्या में आप अपनी सभी क्वेरीज़ के साथ हमारे इस लाइव इंटरेक्शन में पार्टिसिपेट करें, क्योंकि ये सेशंस हम आपके लिए ही लेकर आते हैं। तो सर, जब तक हमारे व्यूवर्स और बच्चे हमसे जुड़ते हैं इस टॉपिक में, हम बहुत ही ब्रीफ में आपसे जानना चाहेंगे सर कि आज के इस टॉपिक में हम क्या डिस्कस करने वाले हैं।
In this particular lesson, we will be discussing the various laws of motion, why motion takes place, what are the various causes, how can we produce larger acceleration, means how can we speed up the objects faster, and for safety purpose how can we make the brakes etc. more effective. We know that motion रुकी तो जिंदगी रुकी. It's very important for us to study various aspects of motion.
तो ये तो बात हुई कि आज के इस सेशन में हम किन अहम बिंदुओं पर बात करने वाले हैं। तो सर, हम इस सेशन की शुरुआत करें?
Yes, sure. Yes.
जी।
Dear learners, in earlier lessons in kinematics, you have attempted to describe the uniform and accelerated motion of a particle in quantitative manner, wherein you have studied the equations of motion which relate the final velocity, the initial velocity, the acceleration, the time, the distances etc. We however did not talk about the factors which cause motion to be uniform or non-uniform. In today's lesson, we will be talking about those factors and we will try to address these basic questions, that is how to change the speed, velocity, direction of motion of the body. Now suppose we have to move a football at rest. Here is a football at rest and you want to bring it to motion. For this, someone must kick it and apply a force. Here the force has changed the state of rest of the football to state of motion. Without force, this would not have been possible. Let us take yet another example. When you left home for the school on a particular day, suppose you left some books on your study table as shown. Here is a study table and you have books arranged in a particular manner in the center of the study table. Back home, where would you expect to find the books? Yes, you guessed it right. Obviously, you will find the books on the table undisturbed as you left them in the morning when you went to the school. This is the setup which you left in the morning and you still have at when you are back home. However, supposing you find the books have been disturbed, as you can see in this picture, the books are displaced towards to the corner of the table. What would you conclude? You are very sure that someone has applied a force to move the books. How could you guess it? You could guess it because from your daily observation, you know that objects cannot come to motion on their own. An object at rest always requires a force to come in motion. Someone has applied the force to move the books from the center of the table to one of the corners. Hence, an object at rest, for example, branches of a tree, they do not move unless the wind exerts a force to move the branches. The books in our example cannot come to motion from rest on their own. A football which we saw in our example, we know it cannot change its state of rest to state of motion without the action of the force. So, all objects continue to be at rest unless some external agent applies a force to move the object. The examples considered lead us to an important conclusion. An object at rest cannot change its state of rest to state of motion without the help of an external unbalanced force.
Okay. सर तो यहाँ पर आपसे मैं एक क्वेश्चन जानना चाहूँगी. जैसे हमने अपनी प्रीवियस स्लाइड में देखा, यू यूज्ड अ टर्म दैट इज़ एक्सटर्नल अनबैलेंस्ड. सो व्हाई यू यूज दिस पर्टिकुलर वर्ड, सर?
We'll come to that and explain that in a bit. Please give me a minute, I'll come
Sure,
to
sir.
the explanation. Now, we have seen that objects at rest cannot come to motion on their own, we need to exert a force. Now, let us see what happens when the object is already in motion. We will discover that objects in the universe cannot change their state of motion unless a net external unbalanced force is applied. The words are repeated again in this slide because they are very important.
Right.
And as I said, I will be explaining the importance of these words. To bring home this characteristic property, the property which we are talking about is object in motion continues to be in motion unless a force acts on it. Let us perform a simple activity. Let us roll a ball on a rough surface and observe what happens. This signifies a rough surface. We are rolling a ball on this rough surface. The ball stops after covering some distance. Now, let us compare this motion of the ball on a cemented floor which is comparatively smoother. It is a plain cemented surface. We are moving the same ball, rolling it with same initial velocity, and as you can see, the ball remains in motion over a longer distance on the cemented floor.
Right.
Yet another case, observe the motion of the ball on a glass surface. This is glass surface. We see the ball rolling on the surface. The ball remains in motion for a much larger distance on glass. Let us compare the three different situations now. The rough surface. The rough surface, the ball is moving and stops covering a short distance. The cemented floor, is on your screen and the glass surface, which is the smoothest of the three surfaces, and on the smoothest surface, that is glass, it covers a much larger distance. Now, we have to probe why does the ball in the above cases come to rest. This is one of the questions which we need to address. Why does the ball cover different distances in the three cases? Why it covers maximum distance on the glass surface than on the cemented or on the rough surfaces? In fact, we have seen the smoother the surface, the higher will be the tendency of the ball to continue in state of motion. In the above cases, we know that the ball comes to rest due to the force of friction. We are already familiar with the force of friction, and sometimes it causes problems in motion. We know it can retard a moving object and bring it to rest. So, in the above cases, the ball is coming to rest due to the force of friction. We can generalize if the force of friction is reduced and gradually somehow we can eliminate this force of friction. A body once set in motion will never come to rest, it will continue to move forever. We reiterate, in absence of an opposing force, the motion will never come to an end. Conclusion is, no force is required to keep an object in motion. The only thing is you need to eliminate the force of friction which is retarding the body and bringing it to rest. You have to eliminate that retarding or opposing force. You do not need any force to keep an object in motion after once setting it in motion. Moving objects come to rest only due to the force of friction. The force of friction needs to be applied to change the state of motion of the ball, as you have seen. Now, let us consider a ball rolling down an inclined plane. Here is an inclined plane, and left to itself the ball will roll down. You can stop the motion of this ball by applying a force against the direction of motion. We know that natural direction of motion is down the plane. So, if you apply a force F upwards against the direction of motion of this ball, the ball can be stopped. So, moving objects can be stopped only if you apply a force. No force is required to maintain uniform motion in a body. By uniform motion, we mean motion with a given speed in a particular direction. If you want to change the speed, means if you want to increase the speed, decrease the speed, or if you want to change the direction of motion, only then force is required. Otherwise, you do not require any force on the body. So, every object in this universe tends to oppose a change in its state of rest or uniform motion along a straight path. This property is called the property of inertia. We are again using the same two terms. An external unbalanced force is required to retard the motion of an object or to stop motion. So, I appreciate that you are actually taking very keen interest and reading the fine points in the lesson, the external and unbalanced. These are extremely important terms when we talk about the motion. Let us see why. Let us take the case of passengers sitting inside a car. Sometimes we know when the battery runs down, you have to give an initial push to the car so that the car may start and then you may resume your journey. Suppose the passengers are sitting inside the car and pushing the car. So funny, they will not be able to move it. In order to give that initial push to the car, they need to come out and apply the force. So that is where the term external comes into picture. If the force is internal, like the passenger sitting inside the car, they are applying internal force. Once they come outside, the force becomes external, and that external force can change the state of rest to state of motion.
Right.
The other word, unbalanced.
Balanced.
Supposing we have a table and two boys push the table from opposite directions with equal forces. The forces F1 and F2 will cancel each other and they form a set of balanced forces, and it is a matter of observation that these forces, the set of balanced forces, will not be able to move the table. So, that is how why we need the words external and unbalanced.
Okay.
Another interesting example is the case of a student on a chair. Sitting on your chair upright, lift your feet up from the ground and try to lift the chair with your feet not touching the ground. You will again not be able to move the chair. However, the moment you put your feet on the ground and try to lift the chair, you will be able to do it. This is what explains the difference between the internal forces and the external forces. The external force is required to change the state of a body to from rest to motion or from motion to rest. Internal forces do not play any role in motion of the body. So, remember, we have got to this conclusion. Now, historically speaking, for a very long time, Aristotle's viewpoint about motion, although it is wrong today, it was taken to go on the motion of the object. Now, what was Aristotle's viewpoint? According to Aristotelian law, an external force is required to keep a body in motion, which we know is a wrong concept. We have taken examples to show that this is not precisely the case. In order to maintain motion, you do not need any force. The only thing which is important is you need to eliminate the force of friction or the retarding forces. What Aristotle missed was the force of friction, because the frictional force was not known at that time. Aristotelian law of motion is therefore a flawed law, incorrect law, and is no longer of our concern. Galileo contradicted the notion that a force was required to keep a body in motion. Another point which Aristotle made was the heavier objects fall faster than the lighter objects under the force of gravity. According to law of inertia given by Galileo, if no net external force acts on an object, the object maintains the same state of motion, that is the state of rest or uniform rectilinear motion. If an object was at rest, it will continue to be at rest. If it was in motion, it will continue to be in motion with same speed in same direction. These are important things. That is what we mean by uniform motion. The term uniform motion implies the speed should not change and the direction of motion also should not change. The above law of inertia was the starting point of Newtonian mechanics. So, Newtonian mechanics built itself on Galileo's ideas and laid the foundation of Newtonian mechanics. Newton gave us 3 laws of motion which go by his name as Newton's laws of motion. Galileo's law of inertia was his starting point, which Newton formulated as the first law of motion, also known as the law of inertia. The law is stated as every object continues to be in state of rest or uniform motion in a straight line unless it is compelled by some external force to act otherwise. Means some external force must change its position from state of rest to state of motion and to alter the state of uniform motion of the object. This law, as I said earlier, is also known as the law of inertia. The uniform motion in fact implies the motion of a body with zero acceleration. Acceleration we have studied in the previous chapter is the rate of change of velocity, that is, if the acceleration is 0, the velocity remains unchanged, constant, uniform. That is, neither the magnitude will change, so the speed will remain unchanged, nor the direction will change. If the net external force on a body is 0, its acceleration will also be 0. The acceleration can be non-zero only if there is a net external force acting on the body. It is to be remembered that all the objects are under the effect of gravitational force. This we are emphasizing because when we have to study the motion of an object or objects on earth or in the universe, remember gravitational force must be taken into consideration. If we miss, we will not be getting the correct results about the velocity, the acceleration and the distances. Secondly, the objects are also acted upon by the force of friction. So, for complete, proper, correct study of motion of objects, we need to take into consideration the gravitational force as well as the frictional force. Hence, for an object on earth at rest or in uniform motion, it will be wrong to infer that there are no forces acting on the body. Simply put, if an object is at rest or in uniform motion, it does not mean that there is no force acting on the body. The body can continue to be in state of rest or uniform motion if it is under the action of the balanced forces, because if the forces are internal, if the forces are balanced, then the state of motion of the body will not change. The state of rest or uniform motion implies that the net force acting on the body is 0, which implies that external forces may be there, but their resultant should be 0. The law of inertia thus gives us a qualitative definition of force. It does not talk about the quantity, means magnitude of the force and magnitude of acceleration, etc. The force is defined as a push or a pull which changes or tries to change the state of rest or uniform motion of a body. A force acting may not apparently change the state of rest. For example, if you push a truck with a force, you will not be able to move it. It is not because your force is will not produce an acceleration, but the force is balanced by an equal friction acting from the opposite direction. So, no net external force means a body at rest continues to be at rest, a body in motion continues to be in motion, a body in motion does not change its direction of motion and continues to move along a straight path. These three observations we can see about the objects when the net external force acting on a body is 0. The tendency of a body to continue in state of rest or uniform motion along a straight line is the property of inertia. We emphasize it again and again because the motion can be understood if we actually understand the concept of inertia. There are three types of inertia: the inertia of rest, the inertia of motion, and the inertia of direction. We will consider the three one by one now. Here are some illustrative examples of the three types of inertia. First, dusting of a carpet. We know in order to dust a carpet, we beat it with a stick or give it a jerk. Initially, the dust as well as the carpet are at rest. If the carpet is given a jerk, the carpet suddenly comes to motion, but due to inertia, the dust particles continue to be at rest. They are separated from the carpet and hence carried away by the wind. Sudden starting of a bus. It is a matter of common observation that whenever a bus suddenly starts, we get a jerk in the backward direction. A simple activity which I will perform now will illustrate what you feel when you are sitting in a bus and the bus suddenly comes in motion. I am taking this as the platform. This is likened to a bus and this pen cap is like a passenger. Now, let us say if the bus suddenly starts, I am moving this platform towards my left, the passenger, the pen cap falls in the backward direction opposite to the direction in which it moves. You can check it again. Now, I will be moving it towards right, it again falls backward. This can be explained on the basis of property of inertia. The passenger, that is this pen cap, was at rest and due to inertia it has a tendency to remain at rest. So, when the bus suddenly starts, the passengers tend to remain at rest due to inertia and hence they get a backward jerk. This is an example of inertia of rest in daily life. Now, another example, sudden application of brakes applied to a moving bus. If a bus is moving and the driver suddenly applies a brake, everything turns topsy-turvy and we tend to fall in the forward direction. This again we can use the same apparatus, very simple apparatus, to show that object or the passengers will fall in the forward direction if the brakes are suddenly applied to a moving object. Now, here see, you have a bus and the passenger. Our passenger is the pen cap and our bus is the paper pad which we are using. Now, I am gently moving it and bring it to motion so that the passenger and the bus come in motion. And then I will suddenly stop it. This is the application of brakes. The bus was moving towards left, the passengers were also moving towards the left. A sudden application of brakes makes the passengers get a forward jerk. Look at it again. Now, I will be moving the platform towards right. So, here the bus is going towards right and we suddenly apply the brakes. Now, the bus stops, but due to inertia the passengers or our pen cap tends to remain in motion and therefore, it falls in the forward direction. So, these are examples which illustrate that a body has inertia of motion and inertia of rest. Another observation in daily life is an athlete has to run a certain distance after crossing the finishing point, because he is in motion and due to inertia the body tends to remain in motion. Therefore, he has to take a few steps before finally stopping or coming to rest. If he tries to stop suddenly, he may get cramps or he will be hurt, because the property of inertia of body has a tendency to maintain the body of the athlete in motion. The third type of inertia, the inertia of direction. There are two examples: the tangential path of sparks from a grinding wheel. You must have seen that a grinding wheel is used to sharpen a knife or scissors. The sparks produced therein, they follow a straight path, because there is no force which can move the sparks along the circular path with the grinding wheel. I have another very interesting example for you so far as the inertia of direction is concerned. This is a wonderful example. I will like you to search and watch some video on the internet. Zigzag path of a hare chased by a dog. If a hare is being chased by a dog, the hare follows a zigzag path. The hare, we know, has smaller mass as compared to the dog. So, whenever the hare finds that dog is very near, dangerously near, and will be able to catch, the hare suddenly changes the direction. It turns to left or right or in some other direction. Whereas the dog, because of inertia, will move forward. This will give hare sufficient time to change the direction and move to the safer distance from the dog. It continues. Very interesting if you watch such a video. So, hare also knows that there is inertia of direction in the dog, and he uses this characteristic or property to save himself falling a prey to the dogs. An example to illustrate the inertia and the forces. An astronaut accidentally gets separated out of his small spaceship accelerating in interstellar space at a constant rate of 100 meter per second square. So, we have a small spaceship. The term small here emphasizes that the mass of spaceship is small, and it is in accelerated motion. What will be the acceleration of the astronaut at the instant after he is outside the spaceship? Given condition is there are no nearby stars to exert gravitational force on the astronaut. So, we are given that no nearby stars exert gravitational force. The spaceship also exerts only negligible gravitational pull. So, practically we can assume that no forces, no external unbalanced forces are acting on the astronaut once he is out of the spaceship. Hence, the net force being 0 implies that the motion of the astronaut will be uniform, because a force is required to change the state of uniform motion of the astronaut. The acceleration of the astronaut is therefore 0. Now, moving to the quantitative aspect of the forces and the acceleration. This relation we get by in second law of motion. First law talks only about the qualitative aspects of motion and the forces. Here we will be talking about the quantitative aspects. As stated, in governing motion, the first law refers to case when the net external force on a body is 0. The body remains in state of rest or uniform motion along a straight path. The second law refers to general situation when a net external force is applied on the body. In such cases, the motion of the body will become accelerated. By acceleration we mean that velocity will change. It may be an increase in magnitude, it may be a decrease in magnitude, or it may just be a change in direction of motion. All these imply accelerated motion. As I have stated, body may speed up, retard or change the direction. This depends on the relative directions of the applied force and the direction of motion of the object on which the force is implied. The second law relates the net external force to the acceleration produced in the body. Before we get to the relation, we have to study a very useful quantity which plays an important role in governing the motion of an object. The quantity is called momentum. Let us explore the quantity of motion contained in a body and the factors which affect the quantity of motion. For the purpose, let us consider a situation shown in the figure. Here you have a bicycle moving at 20 meter per second and a heavy vehicle moving at same speed 20 meter per second. As you can see in the figure, you have a red light ahead. So, both the cyclist and the heavy vehicle are supposed to stop before they approach the red light. Which one of the two can be brought to halt easily? You can easily guess. The lighter the object, easier will it be to bring it to rest. The cycle stops faster with the help of smaller force as compared to the heavier vehicle. So, the heavier vehicle will have larger quantity of motion. In both the cases, we want the motion to end, means we want the quantity of motion to be eliminated. It is easier to eliminate the motion of a cycle than the heavy vehicle. So, heavier vehicle has larger quantity of motion. Our conclusion is more mass, more motion, more mass, more motion, and keep it in mind. Another case, a ball is thrown towards a player at a speed of 10 meter per second and the player is supposed to stop the ball. He applies a force F denoted by small letter f to stop the ball. Now, let us change the speed of the ball. The same ball is now thrown at 20 meter per second towards the same player. He has now again, in order to stop the ball, he has to apply a force which we have denoted by capital F. Comparing the two cases, see the figures below. What we have seen in the earlier slides is being repeated. On left hand side, you have the ball moving at 10 meter per second and stopped by a force small f. The same ball thrown at 20 meter per second is stopped with a force denoted by capital F. It is easy to conclude that out of small f and capital F, the capital F force will be larger. The ball can be brought to halt easily in the first case when it is moving at a smaller, lesser velocity, that is 10 meter per second, as compared to the case when it is moving at 20 meter per second. We conclude more velocity, more motion. That is why in the second case it was difficult to stop the ball. Recall that a helmet is usually used by the batsman facing pace bowlers, because pace bowlers, the speed of cricket ball is much larger, therefore, it is much nastier than the ball coming from a spinner due to a higher velocity. We reiterate, more velocity, more motion. So, the quantity of motion depends on the speed. Similarly, the quantity of motion also depends on mass. Another example which relates quantity of motion and mass is, it is safer to catch a table tennis or ping pong ball thrown with a certain speed than to stop a cricket ball thrown with an equal speed. It is because the ping pong ball has a much smaller mass and therefore it possesses much lesser motion and is easier to stop. The linear momentum or simply momentum increases both with increase in mass and increase in velocity of the body. We can now give a mathematical meaning to the term linear momentum or simply the momentum. There is a relation between the force and momentum which we need to probe. In order to explore the quantitative relation between the force and momentum, let us consider the following experiment. Here in this figure we have an unextended elastic spring. The force applied to the spring is 0 because the spring is not extended. In the second figure, the spring has been extended with a mass attached to its free end. On releasing the mass, we have a pull developed due to the spring towards left. This pull or the force Kx acts on the spring and the mass towards left. For a given extension, the force will be same. Now let us perform this activity by taking 3 different masses, the mass m1, m2, m3. Apply the same force F and record the accelerations a1, a2 and a3 in the 3 cases. According to the second law of motion, something is missing.
So, dear learners, here we are we are discussing about the laws of motion and I am quite sure आप सभी को बहुत अच्छे से समझ में आ रहा है. If you have any query related to this particular topic or laws, आप हमसे जुड़ सकते हैं, आप हमें कॉल कर सकते हैं हमारे टेलीफोन नंबर पर जो है 8800440559. Either you can drop a comment as well. हमारे NCERT official YouTube channel और PMeVIDYA क्लास 11 पर जाकर आप कमेंट ड्रॉप कर सकते हैं. तो आप हम एक्सपेक्ट कर रहे हैं कि आप अपना पार्टिसिपेशन हम तक ज़रूर पहुंचाएंगे, आप अपने क्वेरीज क्वेश्चंस पहुंचाएंगे. हम वापस चलते हैं अपने टॉपिक की ओर जिस पे हम डिस्कशन कर रहे थे सर. तो शैल वी कंटिन्यू? इज इट ओके?
Sure. The second law gives a relation between the force and momentum. According to the law, the rate of change or momentum of a body is equal to the force applied on the body and the change in momentum is in the direction of the force. Mathematically, the relation is F equal to the force F is equal to mass into acceleration, which is dp by dt or rate of change of momentum, or m into dv by dt. So, the second law gives a quantitative meaning to the force. The external force applied on a body required is the product of mass and acceleration produced in the body. The law in its mathematical form, the second law in its mathematical form, that is F is equal to ma, helps us to define the unit of force. If mass is 1 kilogram and acceleration is 1 meter per second square, we are using SI system of units. So, mass is 1 kilogram and the acceleration is 1 meter per second square, then the force is 1 kg into 1 meter per second square. This force is called 1 Newton. For the purpose of definition, we say 1 Newton is the force which produces an acceleration of 1 meter per second square in a body of mass 1 kilogram. Let us take an example to see how we apply the second law in its mathematical form to study the motion. A bullet of mass 0.04 kilogram moving with a speed of 90 meter per second enters a heavy wooden block and is stopped after a distance of 60 centimeter. What is the average resistive force exerted by the block on the bullet? For solution, we record the given information. The mass is 0.04 kilogram. The bullet had an initial velocity, that is u, equal to 90 meter per second. As it comes to rest, it is stopped. Therefore, the final velocity v is 0 meter per second, and the distance given is 60 centimeter, which in SI system or meter is 0.60 meter. The retardation A of the bullet assumed constant can be calculated by the relation 2as equal to v square minus u square. Substituting various values, you get the acceleration and hence the force, which comes out to be minus 270 Newton. Here the force is negative because the force is resistive, or it is stopping the motion of the bullet. This force, we should remember, is only an average force, and it has been calculated by assuming that the force remains constant throughout the motion of the bullet in the wooden block. Another important term which we have to study in relation to motion is impulse. Sometimes a large force acts on a body for a very short duration, and it produces a finite change in the momentum of an object. For example, when a ball hits a wall and bounces back, the force on the ball exerted by the wall acts for a very short duration, that is the duration during which the two are in contact. The force is, however, large enough to reverse the momentum of the ball. So, initial momentum is in forward direction towards the wall and the final momentum is in opposite direction. In such situation, neither the force nor the time can be separately measured. It is very difficult to measure them. However, the product of force and time, which is the change in momentum, it can easily be measured, and this product is called impulse. So, impulse is the product of force and the time for which the force acts. Using the relation F is equal to dp by dt, which we got by second law, we get F into dt equal to dp, that is the product of force and time. The impulse is equal to dp, the change in momentum of the body. So, in order to find the impulse, you need to calculate the change in momentum. Impulse is a vector quantity in the direction of applied force. A large force acting on a body for a shorter duration produces a finite change in momentum, and such a force is called an impulsive force. Historically, impulsive forces, that is large force, short duration, they were conceptually put in a different category. In Newtonian mechanics, we do not make any such distinction. We take the impulsive forces as any other force. However, it is just a large force and acting for a short duration.
Sir, here let me tell you that we have 5 more minutes left for this session, sir.
Yeah, sure, we will wind it up. This is an example where we can easily calculate the impulse. A batsman hits back a ball straight towards the bowler without changing the initial speed. So, initial speed is 12 meter per second Mass of the ball is on your screen 0.15 kilogram. You have to determine the impulse imparted to the ball. Here impulse is the change in momentum. Remember, the direction of the ball has been reversed. So, initial momentum was towards the batsman, final momentum is in the opposite direction. So, initial momentum is mass into initial velocity, final momentum is mass into final velocity. So, we have to attach a negative sign, and the initial momentum, that is 0.15 into 12, is taken as negative. Final momentum is 0.15 into 12. Change in momentum is mv minus mu, which is 3.6 Newton second. This change is directed towards the bowler because the direction of impulse is the direction of force. The force has been applied by the batsman towards the bowler. The third law of motion. The second law relates the external force on a body to its acceleration. But what is the origin of the external force? Which agency applies the external force to, in our case, of the spring attached to the ball? If you pull the spring towards right, you experience a force towards left. That is, the two forces are simultaneously acting on the, in this case, a force which you have applied towards right and the force which your hand experiences towards left. The force which we applied to pull the spring is action, and the force applied by the spring which pulls our hand is the reaction. According to third law of motion, to every action there is an equal and opposite reaction. The action and reaction act on different bodies and hence they do not cancel each other. The law holds even if the bodies are not in contact, as we will illustrate. The earth pulls a stone downward due to gravity. The stone exerts an equal and opposite force on earth. However, we cannot experience the effect of this force because we know earth is very massive and therefore the effect of such a small force is negligible and cannot be observed by motion of the earth. So, now let us quickly sum up what we have studied so far in this lesson. Inertia is the property of an object by which it opposes a change in its state of rest or uniform motion along a straight path. According to Newton's first law of motion, every object continues to be in state of rest or uniform motion in a straight line unless compelled by an external force to act otherwise. This law is known as the law of inertia. Inertia is of three types: inertia of rest, motion and direction. Momentum of a body is the product of its mass and velocity. It measures the quantity of motion contained in a body. The direction of momentum is same as that of velocity. Its SI unit is kg meter per second. According to Newton's second law of motion, the rate of change of momentum of a body is equal to the net external force acting on the body. The momentum is product of mass and velocity. It is a measure of the quantity of motion which is present in the body. The direction of momentum is same as that of velocity and its SI unit is kg meter per second because momentum is the product of mass and velocity. According to third law of motion, to every action there is an equal and opposite reaction. Action and reaction act on different bodies and hence they do not cancel each other.
Right. So those were the Newton's laws of motion, and I am quite sure, dear learners, this chapter and session would be beneficial for all of you. और it's time for me to wrap up this session, but उससे पहले हम अपने विशेषज्ञ और हमारे एक्सपर्ट जो गोगिया सर हैं उन्हें हम बहुत बहुत धन्यवाद करना चाहेंगे. Thank you so very much, sir.
Thank you so much.
Thank you so very much for this insightful session, and I am quite sure, dear learners, आपको भी काफ़ी कुछ जानने को सीखने को मिला होगा. इन केस अगर आपने अभी तक लॉज ऑफ मोशन नहीं पढ़ा है और अगर आपने पढ़ लिया है तो आपको काफ़ी बातें भी रिकॉल हो गई होंगी. और अभी समय है कि हम इस सेशन को यहाँ पे वाइंड अप करें, लेकिन जाने से पहले हम आपको बता दें कि एक छोटे से ब्रेक पे जा रहे हैं. हम ब्रेक के बाद अपने एक और लाइव इंटरेक्शन के साथ हाजिर होंगे जो कि भूगोल के 12वीं कक्षा के विद्यार्थियों के लिए. और हमारा आज का शीर्षक रहेगा मानव भूगोल, प्रकृति एवं विषय क्षेत्र. तो आप इस सत्र में भी अपना साथ यूं ही बनाए रखें. अभी फिलहाल मुझे रेणु भट्ट को दे अनुमति. आप बने रहें eVidya चैनल और ncertofficial यूट्यूब चैनल पर और अधिक ज्ञानवर्धक कार्यक्रमों के लिए. नमस्कार.